In this podcast, we're going to take the skills we've learned so far with our graphing um, podcast, and we're going to use it to solve single variable equations. A single variable equation is an equation like this one in example 1, where there's only one variable in it. And we're going to be using the same 4 steps to do all of these problems. All of them are solved problems with a single variable. So let's get started. Step 1, when you're going to solve by using your calculator, is to get a 0 on one side. Well, the easy side to make a 0 here on is the 5, so I'm going to just subtract 5 from both sides. And so on the left side, I'm going to have 0.25x squared minus 5x minus 5, and the 5 is not a like term with any of these two terms, so I can't put it together with them. All I can do is say minus 5x minus 5. And on the other side, I've made my 0. So I've done step 1, get a 0 on one side. Step 2 says change that 0 to y. So I'm going to take the 0 and I'm going to change it into a y, so it'll say equals y. But instead of having my y on the right, I'm going to put it on the left like it is in the calculator. So I'm going to say y equals 0.25x squared minus 5x minus 5. Step 3 says graph the function and find its x-intercepts. Its x-intercepts are where the function crosses the x-axis. So if it looks like that, it has 2 x-intercepts, one here and one here. And we showed how to do that on the last podcast, so if you've forgotten, you can check. But we're going to do it right here, so you can just watch and see how we do it here. So I'll bring up my calculator. And right now the calculator's not on, so I'll turn it on. And I'll go to my function section. And you'll notice, like in the last podcast, I've already added some functions just to save time. You'll see after we modify it that this second function corresponds to example 2 and the third function corresponds to example 3. But let me put in the equation from example 1, and it's y equal 0.25x squared minus 5x minus 5. So there's the y equal, so I put 0.25x squared minus 5x minus 5. Now we're going to be graphing that, and we're going to want to find the x-intercepts. And I told you on the last podcast that a very slick way to find your x-intercepts was to also graph y equals 0. But we'll go ahead and just graph this first and then move to that. And to get me a quick graph, I'm just going to go zoom 6. And so there's a quick graph, and it looks like it's a straight line. Now that's strange, because look at this power here. We said in the last podcast that if the power was 2, you can expect to get one turn in all likelihood. You may not get a turn, but you should get a turn here, and we didn't see a turn in our graph. If you look at our graph, it just looks like a straight line. So now I'm wondering if our window is big enough, if we're really not seeing this function. So let's try changing the window. Instead of going from negative 10 to 10, my first change would go from negative 20 to 20 and just see if doubling it would help. Negative 20 to 20. I'll put a mark every 5 units so I don't get too many marks. And I'll just do the same in y. Negative 20 to 20. And I'll put a mark every 5 units. And this time you hit graph, not zoom 6, because now if you hit zoom 6, it'll go back to negative 10 to 10 again. So make sure you hit the graph button if you've put your own window in there. So it's still, I was going to say it still looks like a straight line, but it doesn't, because it started off looking like a straight line, but then it came back up this way. So don't you think that it has a turn right down here? Because having a turn would go along with the power of x being 2 in our function. So we're thinking that it has a turn. Now, the turn would be lower, so my y isn't low enough to see it. My y was negative 20, so I'll change that to negative 30. Also, I can't see the x-intercept here. The x-intercept got cut off. We went out to 20 here. So here's what I'm going to do. I'm going to change my x window. Instead of going from negative 20 to 20, I'm going to go from negative 10 to 30. That way, we should be able to see this cross out here, and we don't need all this out here anyway. We'll start the graph here. And on the y, I want to go to negative 30 to see the turn. So I think on the y, I don't really care about what's up here, so I'm going to go negative 10 to I'm going to go negative 30 to 10 on the y. I'll just make a note here so that when we bring up the calculator and change the window, we'll have what we want to change it to. So I'll open the window here. On x, we said we were going to go negative 10 to 30. So there's negative 10 to 30. Whoops, lost the window. You got to go down. Negative 10 to 30. And then on the y, and let's see, is 5 marks enough? Yeah, that's 40 units. So if that's 5, that's just 8 marks across here. That's not too many. Now on the y, we said we wanted to go from negative 30 to 10. So negative 30 to 10, and we'll mark it every 5 units also. Now graph again. Oh yeah, much better graph. You can see the turn down here at the bottom. You can see that it has 2 x-intercepts. You know it doesn't have any more, because since the power of x is 2, it can't turn again. So it has to keep going up here, and it has to keep going up here. So we're looking at the only 2 x-intercepts. So let's, the best way to get those is, we said, was with second trace 5. So I'm going to go add y equals, well, I already have y equals 0 added as a second function. That's how we do it. We graph the x-axis, and y equals 0 is the x-axis. So I'll come over here and I'll hit. Now it can see both these functions, so the next time I hit graph, it's going to graph this function, but it's also going to graph the x-axis. Okay. Now let's see if we can get a trace going on this thing. There's our tracer. We want to get near one of the x-intercepts, so I'll trace out to the left till I get close to that intercept, and then we'll do a second trace 5. So here we go, second trace 5. And that shifted us down to the lower curve. That's okay, that doesn't hurt anything. It says, do you want to use this as one of the intersecting curves? If you do, you hit enter, and we do. So we hit enter. That jumps it up here to the x-axis, and it says, do you want to use this for your second curve? Yeah, that's why we put it in there. So I hit enter again. Then it says, give me a guess, and give me a guess means get close. Well, you can see it's close to where they cross, so I just hit enter again. And it computes my first x-intercept, x equals negative 0.954, and that is the x-intercept, because right there, y is 0. So for my first solution, I'm going to get x equals negative 0.954. X equals negative 0.954. And let's get our second solution by tracing over to the other side. So I'll move my tracer. Well, it untraced, so I'll hit trace. Now these extra steps I'm having to do to get a trace, you don't have to do. I'm just having trouble with my calculator here, so I'm having to do a few extra things. When you hit trace, it'll come up with the tracer immediately. Okay, there we are, near the second point of intersection. So again, I want to go second trace 5. And I want to get a little closer. Well, it says, is this the first curve you want to use? I say, yep, enter. Is this the second curve? Yep, enter. Is this close? Yep, enter. And it gives us our second solution, 20.95. I think I'll just call it 21.0. So we'll say for the second solution, 21.0. So there are our two solutions, the x coordinates of the x-intercepts. Okay, let's try our second function. It says solve 2x squared plus 8.02 equals negative 8x. Step 1, get a 0 on one side. I'll move the negative 8x to the left. When the negative 8x comes over to the left, it becomes positive 8x plus 8.02. And then there's the 0 that we're supposed to get as our first step. And of course we want to change that 0 to a y. So I'm going to rewrite this as y equals 2x squared plus 8x plus 8.02, and bring up the calculator and let's graph that one. Okay, I don't need the first one anymore, so I'm going to arrow over, hit enter. Now the calculator cannot see the first function. We're going to eventually need to find our intercept, so I'm going to go ahead and leave the y equals 0 going and come down here and let it see that third one. So now it can see the third function. That's the one we want to graph, and we hit graph. Let's see, zoom 6 to get our quickie graph. Took us a while, so I guess it was graphing the x-axis first. After graphing the x-axis, it then graphed our function. It's kind of funny looking, but it looks like we've got an intercept right here. So let's hit the trace. We'll trace over there. We want y to be 0. There's 0.5, 0.19. Whoa, okay, now y is about 0 now. However, we didn't see y actually become 0. See there, 0.03, 0.05, and it might have hit 0 right between those. However, other things could have happened too. All we know really is that it's close. Now think about it being close. When a curve comes down and it just is close, maybe it's coming down and it's exactly touching and going back up. But maybe it's coming down and going through a little bit and going back up. Or maybe it's coming down and it's not touching at all and going back up. And we don't know which one of those it is. So what we're going to have to do is kind of try to get a look at it. So I'm going to do a little zoom in box here and try to see if I can see exactly what's going on with that curve. So I hit zoom 1 for box, and I want my box to look at this part of the graph, so I'm going to go up and to the left a little bit, draw my box. So I'm going to click it up 3, over 3, hit enter to make my box. So there's the little box shape. Now I'm going to go back 6 and down 6, and that's really probably not the best shape of box. You know, the function right here is going sideways, so I should have really done a long skinny box instead of a boxy box, but that's okay. So let's see what it looks like. So it's apparently again graphing the x-axis. Does it ever touch the x-axis? It looks to me like it might be staying above the x-axis. It doesn't look like it went below, but I guess to know we'll have to zoom in box again. So zoom box. Now it's a long flat area, so I'm going to make a long flat box. First I trace, try to get to the middle of the area that I want to look at. So there's my tracer. I kind of put it in the middle there because that's where it's most likely to be touching. Now I go zoom box. This time I'm going to do a long flat box like I should have done last time. Go up 3, but I'll come left 6. I'll hit my enter to turn it into a box. That time you could probably see it becoming a box. I'll go right 12. Down about 6 maybe. So now there's a long flat box. That's a good look there. I'll hit graph. Whoops, I don't want to hit graph. Doggone it. I wanted to hit enter. So I'll go zoom box again. Take it up 3. Over 6. Hit enter to turn it into a box. Back 12. Down 6. Okay, I've got everything there in the box. So this time I want to hit enter to blow up the box. And here it comes. And look at that. It never touches the x-axis. So a couple of zoom boxes, we can see the curve never makes contact with the x-axis. Therefore, there are no x-intercepts. Now, if you go back to your zoom 6 picture, you can see one turn here. And since the power of x is 2, it can't make more than one turn. So if you've already seen one turn, you've seen all the turns. That means this can't come back and give you an x-intercept out here or give you an x-intercept out there. It would have to turn again. So we know there are no solutions to this one. So I'm just going to write here, no solution. And just to give myself an indicator of where I'm going to put a little x-axis here and show it not touching the x-axis. You'd want to show something like that if your test question said show your screen. You'd want to show a screen where it wasn't touching the x-axis. Okay, let's go on to the last one. Again, it's a big solve. Now this time you don't have to make a zero because the original equation has a zero in it. All we have to do is change it to a y, which I'm again going to move to the left. 0.014 x to the fourth power minus 0.2 x squared plus 0.03. And I'll bring the calculator up. Of course, I entered that before I started to save a little time. I don't want to look at equation 3 anymore, so I'll come down, arrow over, and hit enter, and that takes the highlighting off 3, but I do want to look at 4. Let's make sure we got it in right. 0.014 x to the fourth, yep, minus 0.2 x squared, yep, plus 0.03, oh yes, that is in correctly. So let's go down and highlight it so now the calculator can see that function. And let's do a quick zoom 6. See if we get anything. So right now we must be graphing the x-axis because nothing was happening. Oh, here's another one of those close calls. Now it's not a close call here. This is cutting through, so we have an x-intercept here. This is cutting through, so we have an x-intercept here. But what's going on here? Is this the same as last time? Is this coming up close but really not touching so that there's no solution here? Is it coming up and touching exactly once? Is it actually cutting through and go above and coming back? You know, the only way we can answer those questions, we're going to have to zoom and box in there to see what's going on. But that doesn't keep us from getting these. Now, we've already put in x equals 0, which is the, y equals 0, which is the x-axis. So we can quickly find our two x-intercepts that we can see. So let's go ahead and start off with that. We'll find this x-intercept and then we'll find this x-intercept. So I'll hit trace. There's my tracer, and I'll trace over to the first one that we want to look at. And we'll do a second trace 5. And it says, is this the first curve? Yeah, hit enter. Is this your second curve? Yes, hit enter. Is this your guess? Yes, hit enter. And it tells us we get an intersect point at 3.76. So I'm going to put, for my first answer, x equals 3.76. Now notice what it gave for y. It's supposed to give y equals 0. 1e negative 13. That's pretty close to 0. That's a point with 12 zeros and a 1. So that's a really, really, really close to 0. And that, for all practical purposes, that is 0. So we can count on that 3.76. Let's trace out to the other side. Trace. Got to move a long way. I'm thinking this will be negative 3.76 because it kind of looks symmetric, but you can't really take that for granted. You have to go out there and actually do the work and make sure you get it right. So I'll do my second trace 5 again. And is that the first curve? Yes. Is that the second curve? Yes. Is that a good close guess? Yes. And for a point of intersection, we get negative 3.76, just what we thought we would. So negative 3.76. And now we have to take a look at this area in here to see, are there no solutions here? Is there exactly one solution here, or are there two solutions here? So that's going to require our old friend, the zoom in box. So I start off with trace. There's my tracer in the wrong spot, so I bring my tracer over where I want to look. I want to look right in here. So, so I go zoom 1 for zoom box. Now it's a long narrow thing, so I'm going to do a long narrow box. I'm only going to click it up 2. Then I'm going to click it to the left about 8. and I'm going to hit enter, and my little plus sign becomes a box. Now I'm going to start drawing my box. I'm going to come over here a long way, try to kind of center it around the axis, come down till I'm sure that I'm below. There, I'm sure I'm below, and I hit graph. Oh shoot, I don't want to hit graph. I want to hit enter. So let me trace it again. So I'm going to zoom box, come up a couple, come over 8. If it's not 8, it doesn't matter. Hit enter, there's my box. Go right about 16, but just make sure it's about the same size on each side. Come down until you're sure you got it in the box, and then hit enter again, and let's see what happens. Oh, it looks like it went over, doesn't it? Do you see it right there? Let's do one more zoom in box. Then it'll be really clear that it's going over. It's so close to being exactly 0 that it's really hard to see. So I'm going to again do a little long narrow box. I'll go up 2. I'll go to the left. I'll hit enter to change my symbol to a box. Then I'll go right till I get all that center stuff, and then down till I make sure I can see everything in the box, and hit enter again. You know, right now it's graphing the x-axis. That's why it's so slow. But you can see, boy, look at it. It's going on this kind of a scale. It's way above. Now it's not really way above. Way up here. Way up here, that's only y equals 0.01. You're looking at 1/100th here. So it looks like a huge thing, but it's not really. Well, let's go ahead and see what our intercepts are. We'll hit our tracer. We'll trace out to the right first. And we'll do our second trace 5. Second trace 5. Is that your first curve? Yep. Is that your second curve? Yep. Is that a good guess? Yep. See what we got for an x-intercept. We got 0.389. So I'll put here 0.389 for an x-intercept, and let's do the one on the left. This looks like it's going to be a toughie, but it may not be so much of a toughie as we think. Let me go ahead and get the tracer working here. There's the tracer working. And now I'll just trace out. If you just hold it on the trace, it'll just trace over there. Now you see that we're not really seeing it, but look what happens when the tracer gets over there. The graph is just going to automatically extend. Well, it's supposed to automatically extend, but it doesn't look like the simulated calculator can do that. If you were doing it on your own calculator, that would have extended this way, and you could have seen the answer. But let's see if this is close enough. I'm just curious now to see if we got close enough to the intersection point, which is out on right about here. Did we get close enough to do this? So I'm going to do a second trace 5. This may not work, folks. Is this the first curve? Yep. Is this the second curve? Yep. Is that going to be my guess? Yeah, it's not a very good one, but that's going to be my guess. And it gave me an intersection. 0.389. Oh, that's the old intersection. Nope, it didn't work. So we're going to have to go back and do this again. So, because this should have been a negative point of intersection, so we didn't get it close enough to get an intersecting point. So we're going to have to change. Well, let's just go back to zoom 6, because it'd be too hard to try to figure this out from the window. And we'll zoom in box right here. We'll come up a little bit, over. Start the box. Come right. Come down. Hit enter. You can see it crossing through right there. So let's see if we can do it from there. Now I'm going to hit trace. Get my tracer going and trace over to where it looks like they cross, which is right in there. So so I want to do second trace 5. Is this your first box? Yes. Is this your second? first function? Yes. Is this your second function? Yes. Is this your guess? Yes. And this time we got it. And it was negative 0.389. So again, the symmetry was showing up. And that completes our podcast on solving by graphing.